Assalamu alaikum guys. Hope everybody will be fine. Today in this video lecture I will guide you for 7 basic points for civil engineers. These points can help you during construction of house as well as if you are working on construction site, so this can help you. Therefore watch this video till the end to learn something new about basic points. What I will teach you in this basic points. The first one for concept of one-way and two-way slab, main bars and distribution bars, how to find weight of steel bar for slab, beam, column, also how to provide extra bar in the junction between beam and column. Practically I will guide you, so therefore this is very important to watch till the end. Let's get started guys. If this video is helpful for you, so you may like this video. The first one is the concept for one-way and two-way slab. Okay, I saw many students, they are working on construction site but they don't have the idea for some technical points, so therefore this is important. So what is one-way and two-way slab? Practically I am guiding you. Okay, one-way and two-way slab, right? Remember guys, suppose this is a slab. Okay, this is a slab, sorry, and this is its longer span, which is for example 6 meter, and this is shorter span, which is consider width. This is length and this is width. Suppose this is 2.5 meter. So how you will know this is one-way or two-way slab? So for that I will give you the example. The example is, as I tell you before, this is longer span and this is shorter span. So the longer span should be divided by shorter span. The longer span should be divided by shorter span. So if the value is greater than 2, okay, so it means this is one-way slab. If the value is greater than 2, from longer span divided by shorter span, if the value is greater than 2, so this is one-way slab. And how you will know the two-way slab? So the longer span divided by shorter span when the value is less than 2. So it means this is two-way slab, less than, greater than for one-way slab, less than for two-way slab. So let me do calculation for this one. This is one-way slab or two-way slab. Then I will guide you for main bars and distribution bars also. So you can see longer span is 6 meter, shorter span is 2.5 meter. So we will get the value when you do division 6 by 6 on 2.5, you will get the value 2.4. So it means this is now one-way slab. What's the reason? Because one-way slab is greater than 2. So now you can see 2.5 is greater than 2. So this slab is one-way. Okay. So now the second point is for main bars and distribution bar. Remember guys, main bar and distribution bars concept is in one-way and two-way slab especially. As you can see, this is one-way slab. So in one-way slab we have main bar and distribution bars. Both we have in this. That's why, because when we place the steel rods on longer direction, you can see this is longer direction. So as you can see here, sorry, on shorter direction, this is shorter. Okay, so these steel rods, these, when we place on the shorter direction, So these steel rods are called, these rods, this is distribution bars. These are distribution bars. But when we place on longer span, as you can see, this is longer span, this is also longer span, and we place the steel rods on longer span. So these steel rods are called main bars. Now what is the work of main bar and distribution bars? As you know, when the load applied on the slab, so slab transfer the load, the concrete transfer the load to the distribution bars, this one, which we place on shorter span. So these steel rods transfer the load to the main bars, because main bars are placed at the bottom. The first point is main bars should be placed on the bottom of the slab, and distribution bars should be placed on the top. So therefore the distribution bars transfer the load to the main bars, and main bars transfer the load to the beam, and beam to the column, column to the footing or foundation. So therefore this is the method for applied load. Okay, now guys, here in one-way slab, remember in one-way slab, as you can see, this is one-way slab. So in one-way slab we provide the beam on opposite direction, on longer span we are providing here in one-way slab. So this is one-way slab. Okay, and two-way slab should be less than 2. The value, when we divide longer span by shorter span, when the value is less than 2, so this is two-way slab. So how you will know the two-way slab? Remember guys, the two-way slab we will place the main bars on both positions, but here for one-way slab the main bar should be here crank bar, like crank bar, as you can see here, like this. We will provide the crank bar. Okay, like this crank bar, we will make it crank at the end of the support, especially at this place, like this. You can see this is the steel rod here, it will come here, then here, like this. So this is main bar. Okay, so here we will provide beams on two opposite side also. So here you can see the loads is applied same like this, also on this side. So this is in two-way slab. Okay, so this is two-way slab. So in two-way slab we don't have distribution bars, we have main bars on both positions. Okay, you can say on each other. Okay, on longer span and also on shorter span we will provide, because this is less than 2, we don't provide the distribution. So it means distribution bars is as well as main bars in two-way slab, but here we provide crank bar at the end of the support on both directions here, because the load are applied on both direction. But here in this case the load are applied only on one direction, same like this, because here we provide the beams on opposite direction. Okay, only on one side, not on two sides. So this is the concept of one-way slab and two-way slab, and also main bars and distribution bars. Now the third point is guys for weight of steel. How we can find weight of steel for beam, column and slab? Guys, for this we have the specific formula, d square divided by 162. Suppose I have a steel rod, this is a steel rod, suppose its dia is 12 mm and the length of the steel rod is suppose 1 meter, and you need the total weight for 12 meter. As you can see here, suppose I have a steel link which is 12 meter from company, from factory. We have the standard length of one steel rod is 12 meter from factory. So therefore this is about 40 feet, you can say. Okay, so how we can calculate the weight of steel? Suppose I am pointing out the weight of steel for 12 millimeter, which length is 1 meter. Okay, so in this case the 12 should be multiplied with 12 d square, so the d should be n millimeter, divide by 162, so you will get the value 0.88 kg per meter. So if you have the length 5 meter, 6 meter, 12 meter, 100 meter, 200 meter, then you will multiply with that, so 12, you will get the total weight. Got it? If this is 12, if this is 10 millimeter, 16 millimeter, so the formula will be this one. You will get the unit weight. With that unit weight for 1 meter means weight of steel for 1 meter. When you do the calculation, d square divided by 162, if you put any diameter 16 mm, 25 mm, 20 mm, etc., 28 mm, then you will get the weight of steel for per meter. Then you will multiply with total length, you will get the total weight of steel rod. Okay, so this is the third one. Now what is the fourth one? So the fourth point is also, guys, very important. As you can see, guys, here we have the stirrup specially for beam, or for stirrups for beam and lateral ties for column. Okay, so guys, we have here this length, hook's length. So this length you can get with the formula of hook's length. You can get with the formula of 10D or 9D you can use. Where D is die of steel rod, this one. Suppose die of this steel rod is, for example, 8 mm. So 8 mm, so 10 is a constant, D is a 8. So it means, so we required 80 millimeter steel length for this hook. Okay, next, guys, the fifth one. The fifth one point is also very important. This angle should not be bent with 90 degree. Same like this. You can see most of the construction I am telling you practically, it should not be provided with 90 degree because this is wrong. So it should be provided with 135 degree. Okay, the fifth one is hooks bend with 135 degree, not on 90 degrees. So this is wrong and this is right. So this is the correct way. It cannot resist during earthquake for beam, column, etc. Okay, so this is the fifth point. Now, guys, the sixth one is also very important, and most of the construction I am seeing this point, that if this, suppose this is a beam, okay, in most of the construction, so this is exposed, this stirrup is exposed to the environment. It means that those people are not providing the concrete cover. Guys, this is not good to provide the concrete cover. Suppose I need 12 inches this, if the column, if the width of the beam is 12 inches, so the ring size, this ring size should be what? It should be 9 inches. On each side we should have 40 mm. So 25 to 40 mm should be the concrete cover for beam and column. This is very compulsory, guys. On construction site, if you are not a technical person and you don't know about civil engineering and you want to construct your house, so the concrete cover should be checked with the help of measurement tape. If that is 1.5 inch, from 1 inch to 1.5 inch, it's okay. So if there is any problem, so you should tell to the laborer, you should tell to the mason, so it should be correct. It should not be exposed to the environment. So after this, the labor and mason or the contractor will tell you that we will do plastering for this. Okay, you cannot get the full strength of the beam or column with a plastering, but you will get the full strength with concrete. So therefore, if this is open, exposed to the environment, so this is not good for the house construction or for beam, for anything. Okay, so the concrete cover should be from 25 mm to 40 mm. This is very compulsory, very important, so you should do it. Okay, the other one is, guys, the seventh one. Okay, so I will write here because I don't have place here. So the 7th point is here also, you can say the development length. What is development length, guys? You can see this is a beam. So here at the end, so the beam should have extra length. So this extra length is called LD, denoted by, so this is development length. This development length should not be less than 12 inches. As well as in column we have development length at the bottom, which we provide on the top of the footing mesh. So this length should not be less than 12 inches. So for that we have also the formula 16D, where D is die of steel rod. Suppose if the die of steel rod is 16 mm and LD, okay, so the LD, for example, for this we have 16D. So 16 multiply 16. When you get any value here, so that will be the development length for column. But here it should not be less than 12 inches. So this is these are 7 important points which I have discussed the front of you. Hope this video can help you and you should follow. Okay, you should implement on construction site if you are making construction of house. So in that place you are also able to apply these things. If you don't apply these things, so maybe you will face more problems after some time in your construction. Thanks for watching. See you in next video. Goodbye.